Okay, I think we're good there. And here's the agenda. Yeah, issue. Yeah. Okay, great. So everyone, this is consensus layer call 137. It is issue 1096 in the PM repo. And yeah, let's go ahead and get started. The agenda is pretty light today, so hopefully, yeah, we can get through everything. So first off, I want to start with Electra, in particular DevNet 1. I think most CL clients are ready for DevNet 1. Um, does that sound correct, everyone? Getting some thumbs up. Okay. I'll assume your thumbs up means your client is ready to go. So then otherwise, I think last time we were waiting on some EL clients to be ready. That being said, I think there are a couple that are ready for DevNet 1. So I would suggest we go ahead and launch the DevNet as soon as we can. I think Pari and Barnabas are out this week. So they are usually the ones doing that. But that being said, I think we can launch it as soon as we're ready. Does anyone oppose that? I think even if there are other EO clients who aren't quite ready, they can just join when they are. Okay, there's a ball pit. We can't hear you. Oh, there's Barnabas. Hi, PK.
Yeah, maybe I can quickly join in. We are currently testing with Teku, Nimbus, Lodestar, and Grandine as the consensus layer clients, and Nethermind and Geth as the execution layer clients. And when looking at the interop chat, I've just found a small issue with Nimbus that should be looked at. But if any other client is ready, please share your client image that we can add that to the testing. Apart from that, all other clients are fine so far.
Okay, great. Sounds good. Um, cool. Then, yeah, I mean, I would suggest we start DevNet 1 next week. If, yeah, that's not possible, then I think definitely by the, well, so it'd be the next ACDE next week. Yeah, I think as soon as possible. And yeah, we'll keep Pectra moving along. Well, one second. Um, okay, yeah, anything else on Pectra or DevNet 1 that we should need to discuss right now? Nope. Okay. Great. In that case, we will turn to Pure DOS. So I don't know if anyone here was on the breakout call the other day, but it sounds like things are moving along. I think there were some issues with the DevNet that they had, but the plan is to move into the next DevNet. Anyone have any Pure DOS updates they would like to discuss?
Yeah, so we have Peerless DevNet 1 running now, and it's currently forking away from every client from every other client. So we really don't have a good DevNet 1. We were thinking about a relaunch, and on Tuesday we discussed that we are gonna be planning for a relaunch by the end of the week. So hopefully by tomorrow we should have client fixes for all the different issues that have arisen on DevNet 1.
Okay, great. Cool. So Otherwise, I have a small update. I had a PR to start to uncouple having the blob counts set on the CL and EL. After some discussion there, uh, what we landed on was that essentially the check, even right now, for the maximum in the EL is redundant, just given the way the engine API works and the checks the CL already does. So the plan there is to actually keep the maximum check just with the CL. That does not need to be sent across the EL because it kind of already happens indirectly with the version hashes. There's then the question of the target. The target, if we want to have the CL sort of drive this value, will need to be sent across the engine API in the same way and also be included in the block header. So that will look like an EIP that presumably we would include in Pectra or sometime in the future. And yeah, I have not had time to get that together, but yeah, just a quick update there. That's where things are at.
I have a question on that topic related to this and this PR and Dankrat's PR. Could you please give us a quick summary on why can't we compute the Bob gas price on the CL and do the validation and send this value to the EL?
Right.
Because in this case, we would not need to add another field to the block header, as far as I believe. We would could just repurpose the excess field to keep this price. I don't know if it would work, but yeah.
Yeah, no,
Sorry.
that sounds right. I mean, the main pushback with so there is this PR that Xiaowei dropped. It's in specs issue or PR 3800. So this one is just basically handling like these max and target values, leaving all of the fee accounting and calculations with the EL itself. There was another PR from Denkrad to basically even go one step further and pull the fee calculations into the CL as well. We can do this. I think it violates the sort of, you know, separation of concerns across the EL and CL that we have and generally is nice. So from what I heard is that implementers with PeerDOS kind of preferred the max and target routes rather than hoisting everything into the CL, but it's an option.
I'm just trying to understand where is the separation of concerns would be broken in this case.
Well, because
Because
it's more like you know, it just seems to make more sense to have like fees and accounting and all of this within the EL because that's like the CL doesn't really care about like the blob base fee, for example, whereas the EL
right,
cares quite a bit.
yeah, but I would argue that actually CL cares because CL handles the networking for blobs and blob propagation. So from that perspective, CL care about this target, and this is why actually we are our intention is to have these marks and target given by the CL rather than defined on the EL. And also, yeah, but from the transaction propagation perspective, here is just one could be one problem, but I don't know how much this price is used for in the blob transaction mempool. Though probably it is important to have this value at hand to build a block and propagate transactions. In this case, yes, it must be on the EL as well, known in advance.
Right. I mean, so the EL definitely needs the target so it can compute the base fee. The base fee is helpful in the mempool and block validation and all these different places. I would say the CL actually doesn't care about the target, it only cares about the max. Um, Again, just even more for like DOS concern reasons.
Yeah, I see. Okay, cool. Thank you.
That's how I'm thinking about it. So I'll keep working on the consensus specs PR and also an EIP, and yeah, we will keep those moving along. If other people feel strongly about, this other option of having the base fee calculation pulled all the way into the CL, like we can explore that as well. Generally, from what I've heard, again, we want to leave that with the EL. Okay, anything else on PureDOS? Okay. Then next up, we had an update on fork choice testing. Let's see, is Ericsson 49, that's the GitHub handle. Are they on the call? I don't.
Yeah,
Yes,
Alex.
yes,
Call.
I am
Oh,
on the
great.
call.
Okay, perfect. You had a presentation?
Yes, I put the link into chat. Oh, can you see my screen?
Yep.
Okay, great. So we have been working on fork choice compliance testing. It's work supported by Ethereum Foundation grant, actually. And okay, so we have implemented a test generator and generated test suites. There is a link to a more detailed report on ETH research, and I quickly go overview of what have been done. So actually, there is more work, but we have implemented initial phase of this generator and the compliance test suites. And our focus was on ease of adoption, minimize surprise to client teams. And in particular, we keep the same fork choice test format without, actually, there is only one small changes. We added new check, which can be ignored initially. And next step will be to work on implementation specific coverage guided fuzzing and using these test suites as seed corpus. And eventually we expect up to 1 billion of test vectors, but it's probably upper bound. Okay. So test generator is implemented. Now we have a draft consensus specs pull requests to put it into the repo. Okay, as I said, it outputs test cases using standard test format. We have also simple Python test runner, which can execute tests using the official fork choice specs. The test generation is parameterized. So there are several parameters and we can adjust them and generate more tests depending on needs. It's currently, one problem is that test generation currently is slow, about 10 seconds per test. We know the problem. It's basically a consequence of compatibility. So we are relying on the existing fork choice testing infrastructure. And because of that, one aspect is that it's kind of slow. However, it can be run in a multi-processing mode. Okay, I hand over to Mikhail to talk about.
Thanks, Alex. So this slide elaborates on the ease part that Alex has mentioned. So we have added just one more check into the fork choice test format. So the test generator produces the fork choice tests in the usual format. And yeah, with just one additional property, which is called viable for head, roots, and weights. Yeah, it can be ignored at the beginning. So it just can be skipped. This check can be skipped. So that's the extension of the format. So it should be pretty easy to integrate this one. Next slide, please. Yeah, so now let's a bit circle back and a bit describe how this test generation seed works. So we have three models written in Minisync, which is the constrained solver language. This is one of the models. It gives us an idea of why do we use it and how it works. I mean, the constraint solver in this particular case. So this block cover model covers the various sets of predicates that are in the filter block tree to define whether the block is viable for head. So on the right, we see the excerpt from the spec. So the predicates are kind of flags, which indicates whether the voting source epoch is equal to the justified checkpoint epoch, whether it is whether this value +2 is greater than the current epoch, greater or equal to the current epoch. So we actually give a bunch of a different set of those predicates. One can be false, the other true, and all this kind of stuff. So we give this vector of predicates to this model as the user input to this model, and this model produces the solution, which is written on the bottom. So this is just numbers and some, some information that will be used by test instantiator downstream, which will produce the test, the folk choice test out of this data and some other. So here what you see is just one solution, but we can ask constraint solver to give us all possible solutions with certain constraints. On the next slide, we have a couple of other models which used to produce similar information for supermajority link trees and for block trees. And the next slide, please. So the test suite config looks like this. There are instances. Instances are those solutions from the model given by the constraint solver that we have already seen. There is also the randomness seed that is passed on the test on the test instantiator input, and the number of variations and number of mutations. Number of variations is the number of variations with different randomness seeds, and this is just the initial one. So the first one will be derived from this one. And next slide, please. So how the randomness seed is used? So this kind of like the block tree instantiator that consumes the supermajority and block tree model outputs and some randomness seed. And for instance, in this instantiator, we take this data and we leverage on the existing folk choice test helpers from the PySpec tests suite and produce the fully functioning, fully featured folk choice tests. And just wanted to mention how this, just want to show how this randomness seed used here. So this particular instantiator works in two steps. First step is to create the tree of supermajority links, given some certain model constraints. And the second step would be to create, to build a block tree based on the most recent justified checkpoint. On these two steps, we use randomness to actually partition validator sets and subsample validator sets that will be built in the blockchain during a certain period of time. For instance, during step one, we create partitions, validator partitions to be active during a certain epoch. So we just use randomness to sample one or more validator subsets. So it can be two, as you can see in the third epoch. We use two validator subsets because we need to build two parallel two forks, two parallel forks. Yeah, and yeah, the next on the next step, this same randomness used to attest to different block tips, and also used to flip the coin when we need to whether the slot will be empty or not, and for other aspects of the test as well. But yeah, this gives some intuition behind how randomness is used. And so with the given supermajority link and block tree outputs from the model, we can apply different seeds and actually get different test cases with different fork choice with different weights for each viable head, and yeah, different and some other properties like empty slots and invalid messages and so forth. Next slide, please. Now to the test suits. Alex, do you want to give?
Yes. I just switching on microphone. Okay, so again, more details can be found in the link. We currently implemented 3 test suites, like tiny, small, and standard. Tiny is like for demonstration purposes, and small is for initial adoption and probably for smoke testing. And so, and standard is like for main testing. And yeah, okay, standard is 13,000 and small is 10 times less, and so on. We also planned to generate extended test suites. However, currently, since test generation is slow and there is no kind of demand for it, we did not generate it, but we can do that in future if needed. There are also links to tests in tar format, links to the generated tests, and yeah. Okay, so a couple of words about test groups. We split our test in 6 groups. Block tree, it does main testing, kind of focus on block trees of varying shapes. And block weight is more focused on producing block trees with variation in weights, to cover get weight functionality. And also have a shuffling group, which focus on shuffling mutation operators. And shuffling basically means that we shift events, kind of delay block or make it appear later, earlier, or drop and duplicate. You can also duplicate messages. Also have a tester slashing group of tests and invalid messages. Yeah, and block cover, which covers various combination of predicates from filter block tree method. Yeah, I hand over to Mikhail again.
Yeah, so we also did with this test suite, we also did integrate it in Teku. So yeah, there was a question about how fast it is to run those tests. So it's like the standard suite with 13,000 tests takes about 20 minutes on my old Mac to run, which is quite fast. So we have found several issues of different kind, like there were 2HKs bugs in the tester session attestation processing in Teku. So yeah, but they're super HK edgy and yeah, unlikely to happen ever, but still. Yeah, what's interesting is the next one is that there were a couple of issues, a couple of failed tests that are related to attestation processing optimizations. So the spec does nothing about optimizing attestation processing, but clients do those optimization to prevent spam on the mainnet. We had the incident a few months ago, several months ago. So and yeah, so actually some of those attestations were not processed by Teku, which is fair. Those optimizations are pretty legit. But this caused the divergence from the test result from what's given by the spec and what happened in Teku. Also, in Teku fork choice test executor deferred attestations from the future, that is coming from the future, for later processing and applies them later on. It's kind of happened implicitly, but it does not defer blocks. And to say that on the mainnet run, it will defer blocks and process them as well, but the fork choice test executor triggers those parts of the functionality in Teku that would not defer blocks. So we have this kind of to deal with this somehow. Also, we ran those that test suite with the coverage, was just standard coverage metric. And yeah, the following functionality appeared to be not covered by the suite. So obviously, with that was expected, that execution payload invalid status and all that is related to it. Kind of like remains uncovered because we do not model this in our test suite. And also there were proto-array pruning threshold is quite large to be hit by our test because we produce those tests with minimal configuration. So it would require like mainnet configuration to hit this functionality. And yeah, on the next slide, we kind of like summarize and open questions to all client developers based on our experience with Teku. So how to deal with the first question is how to deal with the messages from the future. So we have several options here, and ideally we would like to if all clients defer those messages for later processing, then probably this is the way to go. So the suite can do this and expect that the client will implicitly apply the corresponding message when the store time allows to do this. So that would be the best option, I guess. But there are others to think about, and I believe it's pretty much dependent on the fork choice test runner implementation in each client, and on the fork choice implementation at all. So the other one is how to deal with legit optimization in client implementations. So there are two options here. So the first one is to just ignore those tests by each client implementation separately. The other one is just exclude them from the suite somehow. But honestly, we don't like the second one because different clients may have different optimizations, and some will work, some will not work. So excluding them all would be kind of like meaning that we do not test some functionality in some client because the other client does not process this attestation for legit reasons. So those are open questions to think about when you will, when this test suite will be being adopted. And next slide, please. Yeah. So basically, that's all we have so far. And happy to address questions.
Super cool. I have a quick question. Like, how hard is it or easy is it to write these constraint models? Like, did you find that part was like pretty straightforward?
This question to Alex, I believe.
It's probably writing models not very difficult, but making them useful to generate tests can be tricky. Actually, we originally thought about using some kind of test generator would just give us kind of best coverage of state using standard coverage metrics like branch or statement coverage. But in case of fork choice, it's not very interesting actually. I mean, it's easy to get. And so we come up with this solution to use model-based coverage. So for example, we have several predicates in filter block tree, and we want to cover various possible assignments of true and false values to these predicates. And of course, some of them are not probably possible. They can be excluded by some checks in code. But we want basically to have a test case for each combination of predicate which is possible to instantiate. And similarly for blocks and for trees, we can say restrict us to have like say a trees of 8 blocks and just enumerate all possible combinations of such trees, probably with additional restrictions like maximum child count and so on. And so these models, we use these models basically to instantiate models. Oh, okay, instantiate this, enumerate all possible variants, solutions to these models. And basically when we generate a test case for each instance, this will give us coverage that we want. And writing, I mean, it's not difficult, just we need to have some experience with constraint programming, constraint satisfaction programming. It's actually quite convenient, I would say.
Gotcha. Thanks. Ansgar and then POTUS.
Not Ansgar here, or Ansgar with a different German accent. So regarding the letting people or forcing people to forcing the test to leave out tests that people cannot pass. So we kind of have a similar problem with the execution layer tests, where we have some tests that we cannot pass anymore because we, for example, we removed the fork choicer that was needed for pre-merge. So all of the tests that kind of require you to pick between different proof of work chains are stuff that we cannot test anymore, and we just ignore them. So I would also go the route of telling clients like, this is the test suite, and if there are tests in it that you cannot pass because of your optimizations, you should just ignore them locally for your client, but not remove them from the test suite.
Yeah, sure.
Thanks,
Yeah, it's
Marius.
definite. There will be some kind of cases where clients do not pass tests, but that does not mean that this is dangerous, because, for example, if some message is early delayed, but there are multiple copies of blocks and attestations arriving in practice, so I think many failures won't be real problems, and we need somehow exclude them, definitely.
POTUS?
I'm just wondering, how hard is it to change the test generator for other versions of fork choice? I particularly have in mind 7732, but also for PRDAS, if they eventually go to block slot voting, how hard would it be to adapt it?
Okay, we can generate, basically we are currently generating for the NEP, but we also try generating to Altair and Capella, and using mainnet, and okay, we're generating using minimal profile, but generating mainnet is possible, it's just very slow. And for other forks, basically it should be working. Hopefully it will work. You just need to change fork.
So these are forks that change the way that change the fork choice logic, actually. So it's not about mainnet or minimal, or not the form of the blocks, but actually the way we count attestations and the way we weight the nodes.
Yeah. I mean, it still probably work because we just generate these blocks and trees and just can run the same actions.
Yeah.
So I kind of don't know details. Maybe it will require some adaptation. But
Yeah,
in a good, if you are happy if you're lucky, it just works. It will just work.
Yeah, I can add more on this. Probably I will try. So yeah, as Alex said, it might need to even some fork choice changes, some fork choice surgery might require adjusting those models, those constraint solver models that we were mentioning in the beginning. But for this block slot particular case, the empty slots are kind of the product of the randomness seed that is given to the generator. So it probably will be enough just, to do nothing. And this will probably be enough having the empty slots. Yeah.
But Misha, that's very hard to believe, right? So on the block slot, the weight would be assigned to a different node.
Right.
So when you're asking for weights on one of these optional tests, I mean, the result would be very different on one model or the other model.
Yeah,
it shouldn't
of course,
be a matter of like changing.
Yeah, it's not going to be a matter of changing a test generator because that generator uses the spec actually. So it directly calls to the spec. If the spec has this change, if the spec has the block slot fork choice in it, then the generator will just use it and produce the outputs correct, compliant with the spec.
Very nice. Very nice. I think I got it. Thanks.
Yeah, but if there is some change that requires to remove some of the predicates or add new predicates, then we would need to, that's just an example. Then we would need to adjust the model that, works with those.
And probably to improve coverage, you also may want to introduce changes.
Yep. So, are there any other questions?
Okay, if there will be questions, you can write us.
Yeah, just ask us directly in Discord whenever. And also, we're keen to see these adopted by different client implementations. We have a PR in Teku. The PR is listed in the references slide to this presentation. So also those test suits are public, and we have this PR to the consensus specs repo. So please, find a time to try it out, to run it. So the presentation slides are. Yep. Thanks everyone for your attention.
Thank you.
Yeah, thank you both. Super cool. Okay. That was everything on the agenda. Is there anything else we would like to discuss? Otherwise, we can wrap up early today. Okay. Let's go ahead and call it. Thanks, everyone. I'll see you next time.
Thanks all. Bye-bye.
Thanks all.
Bye-bye.
Bye.
Thanks, guys.
Thanks, bye.